Taking a look at 3.1, congratulations on making it to here, the third chapter, dealing with inequalities and their graphs. So what's different? What's new here? With an inequality, this is a mathematical sentence that uses an inequality symbol. The symbols are seen here, 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 and here to compare the values of two expressions. So where have you probably seen this before? Well, if you've used Twitter before, the way that they use inequalities is pretty blown out of proportion because it's saying some excessive stuff like this. Like, for example, money is greater than, I don't know, iPhone 5. No, let's call it the 4. Let's make it that brick. So on Twitter, you've seen inequalities used like this. In the math context, we only use one of them. These should look familiar, so we can use a number line to visually represent the values that satisfy an inequality. So we see less than or equal to, where this can include a number. So notice this can include the original number that you're starting with. This one down here also can too. So it comes down to where the direction is. We then draw an arrow and we figure out if we're talking about less than or greater than or equal to or anything like that. So for example, here we start at 8 and this is saying that all the numbers are greater than 8. So in this case, you would say all these numbers are greater than 8. So that's one example. We see that we're going from the wordy interpretation, the verbal expression, into the equation. So I'll help you through these. All numbers x. This is hinting at what we can probably already write down. So I'll actually read this all one together. All numbers x that are less than or equal to 5. So the first thing I saw was all numbers x, because that's probably going to deal with x, our variable. We then see that they're denoting x, so all real numbers x are less than or equal to 5. So all numbers x are less than or equal to 5. We're done. We then see that we have 4 less than a number y is greater than 10. So this one's tricky. I'm first going to focus on this. So 4 less than a number y. So if we have this number y, we're taking 4 less of that. And this is supposed to be greater than 10. So this should be greater than 10. Ideally, we'll see that x and y could be any number, but really the visual is going to be based off of number lines, but you should also be knowledgeable about how to go from the verbal expression into the equation. So we see that first bit. If you get stuck along the way, please continue looking back at your notes for this section. We'll see that from the inequality, we can then graph these out. So we're starting first with a values that are greater than 1. So I think it's helpful sometimes to list examples. Like you might want to say examples like 2 and 3 and 4. They could all satisfy this inequality seen here because they're all greater than 1. So for example, on a number line, we could throw in 0 for starters. We could have 1, we could have 2, 3. We'll also include some negative numbers too, so we know the difference. We know that we're starting at 1 with an open circle. This is really important. And the reason we're using open circle is because this is not equal to 1. So we're using an open circle because it's not equal to 1. So we see that. We're denoting all the values that are greater than 1. So we want to include, as we mentioned, 2, 3, and 4. So from here, we'll go and draw our arrow to the right. And we're done. You may want to take this time now, pause, try the next few if this seems easy. But I'll speed run through this. So I have a closed circle at 0. And I'm denoting values that are greater than 0. So all these numbers, and we're done. So 1's included, 2's included, 3's included, they're all good. Fair game. Notice that for this one, it can be rewritten. If you prefer to have the variable on the left side, do that, switch it up, make sure it works for you. So 5 was our important number, 6 would be over here, and 7, and negative positive 4. We have an open circle on 5, and we're denoting values that are less than 5, so we want to make this go to the left. Values less than 5. We know this is equal to, so this is definitely going to be an immediate closed circle on negative 3. And if we're denoting values that are less than or equal to negative 3, where are the values less than negative 3? What do you think? Where are the values less than? Hopefully you're saying to the left, to the left. Seen here. Nothing too tricky here. You may want to take this time, try the next few, pause these, try them out, give them a shot. We have 4, closed circle. These values are less than, so make sure this goes to the left. We have negative 5 is less than x. So really, if we switch these around, x is greater than negative 5. This is open circle on negative 5. Line's going to the right. And we're done. We see that we can go also from the graph to the inequality. So I know that this has a few things going for it. And notice I'm listing this. So this definitely has an open circle. This is definitely starting at 4. We also know that if we continue with this path, we're denoting values that are less than 4. So 0 is fair game. So this should be x values that are less than 4. And we're done. Nothing too tricky with these, I don't think. Just take your time, think about the inequality, think about what's changing. If we take this further, we can take a look with a now closed circle. So this is definitely closed. Closed at, well, 1, 2, 3, yeah, closed at 3. And it's going to the right. So if we have our x numbers, if we're starting at 3, what do you think for this one? Should be saying x values that are greater than or equal to 3. We're going to backtrack a little bit and actually talk about example 2. So denoting exactly if we have a point that's a solution. We've seen this previously in some of the earlier chapters, so this should look familiar, denoting if this is going to be a solution or not. So we have these points here for x. We're being asked to decide if they're a solution, because ideally if they are, they'll make the inequality true. So this is saying that we should check if 4 is a solution. 3 times 4 is 12. 12 minus 2 is supposed to be less than negative 1. So this is claiming that 10 is less than negative 1. So what do you think? Is this a solution? Hopefully you're saying no. 4 is not a solution. You can do the same thing for this next one. Checking now if x is negative 3. Follow through it there. 3 times negative 3 will get you negative 9. Negative 9 minus 2. Rewriting the rest. This is claiming negative 11 is less than negative 1. So what do you think about this? Is this a solution? Does this make sense? Is negative 11 less than negative 1? Should be saying this is true. True, because negative 3 is a solution. The outcome is a true statement. If you have any questions on this, hold on to them, bring them to class.